So inverses are where we flip things. So if I want to talk about what happens when I graph the inverse of a function, that means that the graph is reflected over the line y equals x. And the x and the y coordinate of each point are flipped. So they're going to be switched. The y values become the inputs and the independent variable. And the y-axis becomes the horizontal axis. So looking at this example down here, we're going to come back to this middle part in a second, where it says that I have a function, f of x equals x squared, and the inverse, f prime of x, would equal the square root of x. Well, what happens, if you'll notice, instead of it being xy, it becomes yx. So instead of being negative 2, 4, it would be 4, negative 2. Instead of being negative 1, 1, it would be 1, negative 1. 0, 0 would still be 0, 0. 1, 1 would still be 1, 1. But 2, 4 would become 4, 2. And that's how we get inverses. We just flip the points. So we've been using the vertical line test to tell if a graph was a function. If you'll recall, the vertical line test says that if I can draw a vertical line through the function, for example this, and that vertical line only touches the graph one time, then it's going to be a function. But if I take a function and I draw a vertical line through it and it touches it twice or more, this is not a function. So that's what would go in the second blank. If any vertical line intersects a graph at only one point, the graph represents a function. So since inverting something means that it flips it, what it does is if I wanted to find the inverse of this graph, it would actually turn sideways. So we would use what we call the horizontal line test to tell if the inverse is a function. And the horizontal line test works the same way. It says that you take a graph, and if you can draw a horizontal line, and it intersects the graph at only one point, then the inverse is also a function. Well, if I look at this particular graph, the parabola, it intersects the graph twice, so the inverse would not be a function. So question 4 says, what is the inverse of f of x squared a function? Well, again, if I were to reflect it, then it would go through these points and it's going to look like this. So that's actually what the inverse looks like. But if I want to know if the inverse is a function, all I have to do is I have to do the horizontal line test. So for the inverse, I do the horizontal line test. I'm going to call that HLT. It says I draw a horizontal line. If it touches the graph one time, it's a function. 2 or more, so I'm going to put 2 plus, is not a function. So since it touches the graph twice, it would not be a function, because the horizontal line test touches twice. So we're talking about determining whether the inverse is the function. So again, I'm using the horizontal line test. So the horizontal line test is if I draw a horizontal line, it only touches it once, I'm good. So since this one, every time I drew a horizontal line, it only touched it one time, the inverse would be a function. Number 3. If I drew horizontal lines everywhere, well, every single one of those lines only touched it once, so yes, the inverse would be a function. For number 5, if I draw a horizontal line here, it touches the graph 1, 2, 3 times, so no, it would not be a function. Number 7, if I draw a horizontal line here, it touches the graph twice, so no, it would not be a function. And lastly, number 9, if I drew a horizontal line here, this one's a little bit tricky, but it touches the graph here, and here, and here, and here, and here, and here, and all the points in between, so basically more than once, so no, it would not be a function.